Inheritance is one of those fundamental aspects of object-oriented programming. It means classes can inherit properties or functions from superclasses. It means one class can become a base class for somebody else. Now, the good news is you have actually been using inheritance for the most part of everything we have been doing. But now in this lesson, I'm actually going to make my own classes and then have a parent-child relationship between them. Let's see how we're going to do that. I'm going to go to Xcode, start a new project, and I'm going to call it Inheritance Swift. So here is what I want to do and how I'm going to do it. All right, I'm going to write it down first. I'm going to have a class of vehicles, and then my class of vehicles, and I'm assuming this is the vehicles that they go on land essentially. Now I'm going to say that has a subclass called sedans. All right, so I have the vehicles class, and from there we have the sedan classes, and then we're going to learn how to override functions, and then we are going to learn how to add new functions, and that's pretty much most of what really matters. So let's go ahead and get started. I have a class called vehicle, and it doesn't have a superclass. What it does have is this. It has a variable called tires, and that's an integer explicitly unwrapped optional that it must be there. So my vehicle has a number of tires. How many tires are there? And then I'm going to go ahead and say it has an init imp tires, and that's going to be an integer, which, as you can imagine, makes self.tires become imp tires. I'm actually going to go ahead and add one more function of my own as well. I'm going to call it carry weight, and let's call it an integer input weight. So essentially, the other way around. Sorry, I'm writing in Objective-C. So input weight, which is going to be an integer, right? So I have that, and the return is actually a boolean. So whether this is going to be possible or not, and I'm going to say by default carry weight actually returns false unless our vehicle can carry something. So let's see how we're going to subclass this and how we're going to inherit stuff from it. Let me clear things up so we can actually, write more code in here. So the next class I have is a class of sedans. So I'm going to say class. Now, when I'm defining my sedan class, I'm telling myself, well, every sedan is kind of a vehicle. It has to have a certain number of tires, and it can carry a certain amount of weight, and it might have an init that initializes it with certain number of tires. So what if I say my sedan is actually a child of vehicles? Or could read it in a way that sedan has a base class called vehicle, or vehicle is the superclass of sedan. So that's about that. I have this now, and I have a class called sedan, and if I wanted to, I could actually go ahead and use it. Let me again get myself a little bit more space, and then I'm going to use it for you. I'm going to say, let me bring this one down. Okay. All right. So now I'm going to go ahead and say var, let's call, what's the sedan? Let's say Ford Fusion. Ford Fusion. That's a sedan, I hope. So it's a sedan, and the only type of init that it has is the input of number of tires. I'm going to say, well, it has 4 tires. So now my sedan class is essentially the same class as vehicle. It's exactly the same thing. But what if within sedan I had a variable called sunroof, and that would be a Boolean value, and that's specific to sedans, whether they have sunroof or not. And now, as you can imagine, in Ford Fusion, I could go ahead and say sunroof is, for instance, true. The same wasn't valid for something that is made of the type vehicles. In theory, I could go ahead in here and say my Ford Fusion is a vehicle with input tires 4, but then this one is going to give us an error. It's going to say, so what is sunroof in here exactly? Because vehicle doesn't have a member called sunroof. So far we managed to have a class that borrows some stuff from its parent class. Sedan borrows from vehicle, and adds its own set of parameters and attributes. Sedan can also have its own init. So for instance, I'm going to assume every sedan has a number of tires which is 4. So I'm going to go ahead and say init imp sunroof, which is a Boolean value. And then inside the body of my init, I'm going to say the first thing is I have to initialize this based on its superclass. So I'm going to say super.init, and it's going to say, well, what's the number of the tires? I'm going to say the number of tires is always 4. So whenever a sedan is being initialized, that's going to be 4. And then I'm going to say self.sunroof is going to be input sunroof. So now we have a new init for our sedan that does initialize our object based on a sunroof, and we can use that. So I'm going to go in here and say sedan input sunroof true. And I don't need that line anymore. So what happened so far? We have a base class. The base class has its own initializer. It has a variable in there. And we have a child class or a subclass. And our subclass has a new property or a new attribute. And it has a new init. Now, here's another thing, a very common situation that happens. Sometimes you want to override an existing init. So how are we going to do that? I'm going in here and say override init, and it says, well, you're trying to override init this one. Yes, that's the one I'm going to do. And what are you going to do? I'm going to say super.init, put the same value in there, all right? Or if you want, manually put 4, which kind of renders this one moot. Now, the next thing I'm going to do is I'm going to say sunroof is false. So by default, whenever I override this init, I'm going to get the sunroof to be false. And that's overriding an initializer from our superclass. Imagine if in your initializer you have to do something different than your parent class, and that's when you override an initializer. You could, of course, override an existing function. I could go in here and say, as you can imagine, there is no order between the methods. I'm just writing it in here so it's easier to zoom into the screen. I'm going to say override function, and the function I want to override is this guy. So now in this override, I'm going to say, well, it doesn't always return false. If imp weight is below 2000, then return true. Else, let me put the else over there as well. I'm trying to be more economical with my space. Else return false, of course. So that's about, overriding a function. So that's pretty much the basics of inheritance. You have a class, that class has some stuff in it. You subclass it to another one, and that one can add its own stuff. Override functions from parent class, override inits from parent class, have its own specific inits, such as this one, and work essentially independently. Something you might be wondering is, so why would we use this, or when do we use a situation like this? Almost entirely always. And that's a principle of object-oriented programming, trying to modularize your code so it is essentially easier to write and to read. So if I'm writing an application, let's forget about the vehicles and sedans and whatnot. Let's imagine I'm writing an application that's a real estate listing application. You have multiple different types of real estates, right? So for instance, you have listings that are for sale, you have listings that are for rental, and then you have listings that are residential, and then you have listings that are commercial, and then you have listings that are in the city, all right, and then you have listings that are perhaps out of a state, or whatever that you are trying to do. There are a lot of different things that are common between all of these things. So in a situation like this, I would go ahead and say class property, and then subclass sale, and then from subclass of sale I would get something called residential. Let's quickly demonstrate that. I'm going to say class, let's call it property, and this is a class that has the building blocks of a listing that you can have in your app. And then I'm going to have a class, and that class is going to be sale, and that's a subclass of property, and then I'm going to have another class that's going to be residential, and that superclass of that is going to be sale. So it's essentially a hierarchy of different objects that they inherit from each other. Everyone is a property, everyone is for sale. So let's imagine everyone has something called price, right? So price is an integer value, for instance. So everybody has a price. And then the ones that are for sale, they also have availability, for instance. So let's go ahead and say var availability, and that's going to be a date, right? And then the ones that are residential are, for instance, they have something called variable number of, or just rooms, all right, which is the number of the rooms in that available, you know, residential for sale property, so on and so forth. You know, all of these things, they essentially trickle down, they go from one to another, and that's how your code becomes more and more modularized and easier to read and easier to understand. We will see a lot of these kind of things in the coming, you know, examples and the actual apps that we make. We try to subclass as much as we can. Another thing that, you know, you often end up doing is subclassing something that already exists. For instance, let's say I want to get a class called myString to be a subclass of NSString, because I want to add an extra function to it. I want something to happen in here which the NSString doesn't do it by default. Let's say I'm working on an app that has to, I don't know, to reverse every string that I give to him, and I want to have that a built-in feature of NSString. So I can just go in here and add a new class that inherits everything from NSString, but also has some extra stuff in it. And we will see more of these when we talk about class categories and class methods as well. For now, if you have a class, this is how you subclass it. This is how you inherit from that one. You add your own stuff, you override functions, and you use them independently. That's about that, and let's move on to our next lesson.